let's take a look how we can take a figure and use dilation to make a transformation. And so I've gone ahead and graphed my original 4 coordinates. If you need to pause the video and graph those points yourself, go ahead and do that. And I think what I'm going to do in this particular example is I'm going to rewrite my coordinates as a matrix. Now, it's not necessary, but I think it might be somewhat helpful. So I've set up my matrix. Recall that we set these up as x on the top and y on the bottom. So there's coordinate m, and if we finish that out, there's coordinate a, and t, and h. And one way that we can perform a dilation is to use scalar multiplication, which you may recall from a previous video just means writing a number outside of a matrix and then basically distributing or multiplying everything in that matrix by that number. So in this case, the scale factor of my dilation is going to be 1/3. If you watched our last video, we know that a scale factor of a number less than 1 is going to have the effect of reducing that or making a smaller image when we're done. So this is the scalar multiplication. Maybe you recall this from another video. And so what I'll do is literally take everything, every single number, the x's and the y's, and multiply them all by 1/3. So in other words, distribute. Okay, if you want to pause it and try these calculations yourself just to be sure, go ahead and do it. Otherwise, here's what I'm going to get when I multiply everything by 1/3. Some of you may have, or may be realizing, or maybe you already realize, that all I'm really doing is dividing by 3. Multiplying by 1/3 is the same as dividing by 3. So there are my new coordinates. What I'd like you to do is go ahead and graph those, pause the video and graph those, and let's see if this does actually have the effect of making a tiny little quadrilateral instead of the one we have. Graphing those points, I can see it did exactly what we predicted. We have a scale factor, a shrunk down version of that original quadrilateral. In fact, we know it's exactly 1/3 as big as the original. And remember, we want to include labels and primes, so I've gone ahead and done that. If you forgot to do it, make sure you've got that in your notes. And let's take a look at one more example. This time we want to perform a composition of transformations. You hopefully recall that a composition just meant we're doing 2 or more transformations to one set of coordinates. So first thing I want to do is I want to do a translation rule, a slide. I'm going to move it 5 to the left and then up 1 according to the rule. And then the second thing we'll do is we'll perform a dilation on those points. And we want to have a scale factor of 2, meaning our final figure will be an enlargement 2 times as big as the original. So let's go ahead and take a look at how this is going to work. So first thing I would recommend you do is let's go ahead and set up a chart like we used in class. So I'm going to go ahead and separate my pre-image points right there. I'm going to call this first column image 1. Those will be the coordinates I get once I perform the translation. And then the second column I'll call image 2, and this will be what I get after I perform the dilation. Okay, if you have colors, that might be a good idea to do these in colors. So let's go ahead and find where image 1 is going to end up once I follow this rule, adding 5 to the x and adding 1 to the y. Now we could do this visually. I think this time I'm just going to go ahead and do it mathematically, where I literally just add 5 to the x coordinate, so I'd end up with 1, and then add 1 to the y coordinate, so I end up with 1, 2. Notice I called that point A prime. I'll do the same for B and C prime. So add 5 to each one. B prime would be 3, 3, and then apply that rule to find C prime, and that's going to leave me at 3, 2. Okay, if you want to graph that, you can. I think for this one, just for time, I'm going to go ahead and just graph my final image when I'm done. In order to find a double prime, remember I'm going to use the points that came from the column before. So using the point 1, 2, oops, it's going to be B double prime down here, and then C double prime. I want to go ahead and perform a scale factor, or perform a dilation with a scale factor of 2, meaning I'm going to take every single coordinate, both the x and the y, and multiply that by 2. Okay, that'll have the effect of doubling the size of this. So from the column where I left off to find A double prime, if I multiply each of those coordinates by 2, I'd end up with 2, 4. Again, for B double prime, let's go ahead and use those and double each one. So I ended up with 6, 6. And finally, for C double prime, I'd end up with 6, 4. So those should be the coordinates of my final image once I've both translated it and dilated it by making it twice as big. So go ahead and pause the video, get those points graphed. Let's see if it looks like we're predicting it's going to look like. So there's my final image after I translated it, and I can see that, yeah, it did get moved To the right, it did get moved up 1. Now, it moved further than we think it should have, just because the dilation also not only made it bigger, I can see that the triangle is much bigger, it also kind of pushed it away from the center a little bit, so that's why it's moved a little bit more than 5 to the right and up 1. Although if you graph image 1, you'll see that it did move that far in our first step.